Assalamualaikum. I am Wan Abrahare bin Wan Muhammad Sofi and my ID is MA19109. I'm gonna talk about introduction. Data used in the Moody diagram were first published in 1944. Since then, there have been many innovations in pipe material, pipe design, and measurement techniques. This project was to investigate the improvements or enhancement applied to Moody chat as in line with current technology development. There also an upgrade for material use, design, and also measurement techniques of the pipe. A research have been done to determine how this chart had been improved in order to produce a significant and accurate measurement of friction coefficient. As we know, Moody chart can be used to estimate the friction coefficient of flow in pipes. Friction coefficient or friction factor in general was found to be function of Reynolds number and pipe relative roughness. Thank you, that's all for me.
Assalamualaikum. My name is Muhammad Hazarul bin Muhammad Nawawi. My membership number is MA19110. Now I want to present about the literature review. In engineering, the Moody chart or Moody diagram is a graph is in non-dimensional from that relate to the Darcy-Weisbord friction factor, FD, Reynolds number, RE, and surface roughness for the fully developed flow in a circular pipe. It can be used to predict pressure drop or flow rate down such a pipe. Okay, Moody teams then identified that available information can be used to show the flow of the fluid in a rough pipe by referring to the dimensional quantities below. Reynolds number, pressure loss coefficient, diameter ratio of the pipe, relative roughness of the pipe. They come up with an idea of a plot that combines all of the collapse onto a series of lines, now known as a Moody's chart. Okay, next, this example of the Moody chart. The friction factor in fully developed turbulent pipe flow depends on the Reynolds number and the relative roughness, which is the ratio of the mean height of the roughness of the pipe to the pipe diameter. Okay, next, the Colbert equation is implicit in F, and thus the determination of the friction factor requires iteration and approximate explicit relation for F was given by S.E. Hallen in 1983. As the equation is T, this is the equation. The result obtained from this relation within 2% of those obtained from the Colbert equation. If more accurate results are desired, above equation can be used as good first guess in a Newton iteration. When using a programmer calculator or spreadsheet to solve for F. For the laminar flow, the friction factor decrease when increasing Reynolds number, and it independent of the surface roughness. The friction factor is minimum for a smooth pipe, but still not zero because of the no slip condition, and increase with a roughness. The Colbert equation in this case is zero, reduced to the Prandtl equation express the equation. Okay, next. The Moody chart first applied friction factor for the pipe flow by L.F. Moody, ASME transaction, November 1944. The pressure drop characteristic of fluid and used to calculate pressure drop or flow rate or pipe diameter. Okay, the problem with the Moody chart is that we must read in an interactive manner. If it is used to calculate flow rate or pipe diameter, the chart can be read in a direct manner, or if it used to calculate pressure drop. To illustrate, if a chart is from X, Y, vs X, the chart can be read in interactive manner. If Y is given and X is to be determined, it can be read in in a direct manner only if x is given and what is to be determined in the Moody chart. The x-axis is a function of flow rate and pipe diameter. The y-axis is a function of flow rate, pipe diameter, and pressure drop. The chart parameter is a function of pipe diameter. That's all for me. Thank you.
Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is Amira binti Muhammad Fauzi with ID number MA19103. Today I will explain the methodology of our project assignment. So the aim of this project is to know whether there is any improvement or enhancement that have been done to the chart. The Moody chart can be transformed to a form that is read without iterating. This requires that the chart be transformed so that flow rate, pressure drop, and pipe diameter each appear singly on the axis, and the parameter. For example, the chart could be transformed so that the flow rates appear only on the x-axis. The pressure drop appears only on the y-axis, and the pipe diameter appears only on the chart parameter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rosdalillah binti Ramli and my ID number MA19101. So today I want to present the part discussion. So basically this project has been done to determine on how this chart had been improved in order to produce a significant accurate measurement of a friction coefficient, as we know that Moody chart can be used to estimate the friction coefficient of flow in pipes. So the objective of the project is to improve the understanding of using Moody chart in order to have significant result for the problem, as we need to identify the friction factors from the chart to find pressure drop or heat loss of the pipe. So since limitation is too long, so I will summarize limitation of Moody chart. So limitation of Moody chart is only discrete value for such surfaces in which the equivalent cell roundness height, as the shown on the diagram on the report. So variation in surface texture arising from differences in a wide range of factors such as manufacturing, wear, corrosion, vibration, and many more. So, more recent results indicate that many uniform and non-uniform resonators do not follow the Cockburn function is the transitional rock and region. So I think that's all for part discussion. Thank you.
Hello, Assalamualaikum. So my name is Nina Ashikin binti Rajadullah. My metric number is LA19107 and I will be presenting the last part of this presentation, which is conclusion. So for the conclusion, we need to know how to use and apply the Moody chart. We believe the improvements that have been done is more easy for us to interpret or read the Moody charts. So being able to determine the changes and know on how to use the Moody chart are some of the benefits that we have through this research. As we know, as an engineer, we need to be able to solve the problem correctly. So that's all for our presentation for Moody chart topic for the project. Thank you.